Hi, this is Ryan Agro, and in collaboration with Thomas Smith, Mitchell Orelli, and Ziquang Z, we comprise MEM Group 7. Our project was the Solar Thermal Internet of Things, and our sponsors were Professor Ryan O'Connor from Splunk and Dr. Richard Parnas from the Yukon School of Engineering. We worked with the Spring Valley Student Farm, a student-run farm in Mansfield, Connecticut, to design an Internet of Things for their solar thermal heated greenhouse. Our objective was to create an in-depth and innovative solution for the farm to follow. Our solution needed to be easy to use, secure, and thoroughly documented. We partnered with a software company called Splunk and used their platform to design our end product for the farm. The reasons for this project are to create data and transparency for the students and professors using the greenhouse. Essentially, they need a way to know the status and metrics of their system when they aren't there in person.
Our plan to tackle the main objectives of the project was to start from the base requirements and work our way up. The initial plan was to first do research on solar thermal heating to determine what metrics would be useful to track, which would help us determine which IoT sensors to use, allowing us to collect data, upload it, and display the results in an informative dashboard. Our initial plan was impacted by the unprecedented global situation, and we subsequently had to pivot from the steps that involved in-person visits to the farm, such as setting up the sensors to collect data, to finding alternative ways to represent our ideas, such as using local weather data in its place. Our final plan, therefore, primarily shifted to providing the framework for future progression of this project.
For our results, we were able to create a dashboard with several real-time metrics using the Splunk software. We pulled data from the National Weather Service for the temperature and cloud coverage at the farm. These are important metrics to use when adjusting the flow rate within the heating system. The dashboard also has the temperature, voltage, and CPU usage rate of the Raspberry Pi. These are useful for seeing the system efficiency. The dashboard is available online as well as the Splunk app. As we were unable to complete the connection between the data logger and to Splunk, we were able to create a progress plan, a step-by-step handoff guide for future progress groups. This provides the code and hardware procedures necessary to complete the project. We want to thank our sponsors Richard Parnas and Ryan O'Connor for their expertise and support throughout the project. Thank you.